configuring port security. Simple, straightforward. We're not going to go too much into details. Essentially, what port security does, it allows for us to have control over which devices can access the network. And as you can see, the trunk port is up between the two switches. We're going to go through some basics as well for how switches learn MAC addresses. And yeah, let's start. So step one, the MAC addresses of each switch appears in each other's MAC address table. Why? Because of BPDUs, Bridge Protocol Data Unit. So a Bridge Protocol Data Unit is an STP concept, spanning tree protocol concept, where when switches are connected together, they send BPDUs throughout the switch network to learn about the switch's priority, its MAC address, so that it can make an election decision as to who's going to be the root bridge, right? That's just basic STP stuff. I'm not going to go too much into that because that can get crazy, right? And again, since we have been talking about cybersecurity a little bit here, switches can be configured to have a BPDU guard. A BPDU guard prevents rogue switches from gaining access to the network, right? So all you got to do is activate that. You typically want to activate it on the access ports, which has port fast enabled. That's ideal. And yeah, so let's check the MAC address table real quick. All right, so we can do show MAC address. I think this is the correct syntax for this. Table dynamic, right? And we can see here that switch 1 learned switch 2's MAC address dynamically via G01, right? So since we have this I guess this entry into the table, we can assume that bridge protocol data units are being propagated throughout the switches, or they're exchanging them for sure. And we can assume that this is on the up and up, right? Cool. So step 2 is, since no traffic has been propagated through the switches from the PCs, the switches hasn't learned their MAC addresses yet, right? So how do we get some traffic going? First of all, since we're being careful here, since we're talking about port security can extend beyond just configuring the commands to allow or deny certain MAC addresses, right? We want to essentially harden our network by shutting down unused ports. That's some basic layer 2 best practices right there, right? So how we do that is we could just do interface range FA02 to 24, right? Oop, we got to put range, interface range, because these are the ports that we're not using right now. And then we just do switch port mode access, so that we can know for sure that they're not going to propagate any DTP messages, right? And then we can do we can do switch port no negotiate, to definitely make sure that DTP, no trunking is going to form at all whatsoever. No DTP messages are going to be propagated or anything like that. Switch port mode access just puts it into a static access mode. I mean, it would not be able to trunk at all because it's in access mode, but we want to be extra super careful and put no negotiate so that it doesn't propagate any DTP messages between any rogue switch that's trying it, right? Next thing we want to do is we want to shut down all the ports. So we shut down all unused ports, and as we mentioned earlier with NTP, this is a syslog message, and this is the notification. This is severity level, and we can also include timestamps and sequences in our syslog message, which is essential for, again, auditing, troubleshooting, and recovering, like Lewis said, right? So this is the Cisco part of it. You can also send these syslog messages to a server and view them later on, right? To audit them, right? Now, we also can do interface G02 because we're being super careful here, right? And we're gonna do the same thing. Switch port mode access, because this is another unused switch port. And we do switch port, did I spell that correctly? Switch port no negotiate, and then we shut it down. So all of our ports are pretty much shut down that we're not using. The ports that we're not using, they're shut down, and we can move along with our port security configuration, right? So where are we now? So yeah, no traffic has been propagated through the switches from the PCs. The switches hasn't learned their MAC address. So we're gonna change that. Right now, we're going to send a ping. Let's see if they have IP addresses. Yeah. These two switches, by the way, are sharing VLAN 1. Also, that's another security issue. We shouldn't be using VLAN 1, but we're not gonna change the VLANs right now. We're just going to continue on with the lab, right? So we don't use VLAN 1. We usually switch the VLANs to something else, but these two PCs are going to be able to communicate with each other because they are in the same VLAN. So they don't need a router to propagate the messages beyond the subnet boundaries, right? So they're both in the same subnet, and we're just going to send a ping to the other device so that we can start learning the MAC addresses. We get a reply. That's good news, which means that these switches should have learned the MAC addresses, right? Great. So as we can see here on switch 1, it learned 2 different MAC addresses from G01, which makes sense because it learned the switch's MAC address itself, and it also learned PC1's MAC address, which was learned through a frame propagated through this switch and through this switch, right? Let's save this before it crashes because Packet Tracer always crashes on me. So we know that much, right? And we also know that since PC0 is connected to FA01, we know that this is its MAC address, which is going to be pertinent information for when we want to start setting up some port security settings, right? Let's look at switch 2. Switch 2, pretty much going to be the same thing, because when it comes to pings, we need two-way reachability, right? We need it's going to be a ICMP echo, and then it's going to be a ICMP echo reply, right? So that's two-way reachability, and the switches should know the MAC addresses of these devices because of that communication. And as we can see here, you're right, we have two, man, I should have, no, it's all good. I'll be able to figure it out. We have 2 MAC addresses learned on G01, and we have 1 MAC address learned on FA01, which is obviously the PC that's connected to that interface, right? Now, what we're gonna do is we're gonna move on to configuring port security, right? So what we wanna do is we're gonna only set it up for FA01 on each switch, right? Keep it super simple. So we're gonna go into interface FA01, switch port security, right? Oh, command rejected because Fast Ethernet 01 is a dynamic port. That's a key to, you gotta notice for the exam, to configuring switch port security. Switch port security can only be put on static access ports, right? So switch port mode access. It's all good now. Now it's allowing us to configure it, right? And switch port security. And then now we have many different options here, right? We can set the port security aging commands, MAC address, a secure MAC address, which is what we want to do here, maximum secure addresses, and we can set the security violation mode. Now, when we activate switch port port security on an interface, it's configured with default settings. The default settings is only one MAC address is allowed at a time, right? You can configure that to be maximum, whatever you want it to be, and you can set a violation. The default violation is shutdown. We're gonna go more into the violation modes later on. Matter of fact, let's do that right now. So the violation modes, we have 3 options to choose from. We have shutdown mode, which is the port is shut down and it's in an error disabled state. And the only way to bring that port out of that error disabled state is if we log into the switch, right? And we issue a shut, no shut, right? Shut down, no shutdown. We're shutting it down, bringing it back up. That resets the interface, right? Or we can set an error disable recovery timer. We can set it for 15 minutes, 15 seconds, whatever, right? Now that is the most aggressive violation mode, right? It shuts it down, it creates a log message, and it's shut down indefinitely, right? And it discards the frame, of course. Restrict mode, it's a little less strict, right? The frames from the unauthorized addresses are dropped, no log entry is created, and the interface remains up. It's a little bit crazy, right? No, I think a log entry is actually created. I think I might have mistyped that. In restrict mode, the log message is actually created. I might have mistyped that. Let's see real quick. Because let me see. Yeah, so in restrict mode, frames from a non-allowed address are dropped, a log entry is made. So that was a typo, right? We can see that right here in our portable command guide. This book is really good. All right, Lewis, I gotta go. I'm at work and I have a meeting, so thanks for the great content. I'll come by next time. Yeah, thanks, bro. Appreciate you. Thank you for stopping by and dropping some gems. Have a great day at work. See you next time. So the restrict mode, yes, that was a typo. This is the portable command guide, by the way. That's what I meant to say. This is really good for your studying the commands for the certification. I wouldn't recommend you write these commands out. I'd recommend that you apply the commands and learn them as you go. And essentially, that's what it is. So when you apply the commands, also I want to state, when you apply the commands, they become so second nature to you. If you're really about this Cisco life and this networking life or IT life, like it becomes ingrained in your mind, right? So let's get back to it. So restrict mode, that was an error. Let's save that real quick. Now, restrict mode, frames from unauthorized addresses are dropped, log entry is created, the interface remains up. That's good. Protect mode, frames from unauthorized addresses are dropped, no log messages are created, and the interface stays up. Cool. We're gonna keep it at shutdown mode for the violation, right? So where were we? So now what we wanna do is, what's step 4? Yep. We're going to configure each PC's MAC address as secure MAC addresses on the ports they're connected to. All right, great. So we're gonna do switch port security MAC address And then the MAC address of PC1 is FA01, right? That's easy. I think we can just copy and then paste. Yes, we can. So that is the MAC address, the only MAC address that's allowed on this interface. So also we can do this. We could do switch port security maximum. Understand that, I don't know, maybe in your practice test or what have you, gonna have to work on these port security commands, because there's a few commands here that variations of the commands, and sometimes it will trick you up. It will trip you up, right? Switch port security maximum, we're gonna put 1, right? So we can do switch port security violation. This is how we set the violation, and we're gonna do shutdown. Let's look at the, let's do this. We have three options: protect, restrict, and shutdown, as we went over just now. I'm gonna go with shutdown. And the context sensitive help, little question mark, is great because it allows for us to, you know, kind of look at what our options are, what our possibilities are, right? So we got all of that set up, and yeah, we're good to go on that, right? But we're gonna do something a little bit different on this switch to switch it up a little bit. No pun intended. So interface FA01, we know that needs to be static access. Switch port mode access, switch port security, and then we're gonna do switch port security MAC address sticky. Now, sticky MAC addresses is essentially allowing for port security to learn the MAC address dynamically and then save it or put it in as a secure MAC address, right? So that's convenient for us, right? And we know switch port security maximum 1, right? And switch port security, we can do, let's do restrict, because I'm gonna try something. I'm gonna restrict it. Switch port security violation restrict. Oops. Violation restrict, right? We're gonna play around with this a little bit. So now let's generate some more traffic so that the sticky feature will work for here, right? And then now let's check the switch. Switch 1, show port security. Oops, of course it's unrecognized because I didn't put the do command. Do show port security. Question. Let's just go ahead and do this. Let's just start over. Do show port security. Is that the right one? Yeah. So right now we see the max secure addresses is 1. Current address count 1. No security violations, and the security action that it's supposed to take is to shut down in the event an unauthorized MAC address comes across this interface, right? There's another one, show port security. Let me see, I think it's this one. Wait. Yeah, so what we can see here is the last source address in VLAN, right? This is PC1's MAC address, and it's in VLAN 1. And it's good, right? It's good to go. Now let's look at this switch, do show port security. And then we see the maximum amount of secure addresses, 1. Current, 1. Security action, restrict. So we see it learn the MAC address through the sticky dynamic configuration that we put. right? And it learned it dynamically, right? Just in case you guys don't know, I always wear headphones, but I do have ears. See, I got ears. So some of you might be wondering, yo, does this guy have ears? But yeah, let's get back on topic. So we see that it learned, or it configured, a secure address using the sticky command. Now let's do show port security interface FA01. Keep forgetting the do command today. And then we see some more information, right? Showing these show commands because they're important, right? Should know these for your exams and your studies and stuff like that, right? Now what we're gonna do is we're gonna start violating, right? This is what we're gonna do. We're gonna start triggering the violations by taking a different PC, right? Taking two different PCs. Let's put PC 0 and PC 1 over here. Let's say a would-be attacker tried to take control of this network through this PC or whatever they're trying to do. I don't know what attackers be trying to do these days. Data breaches, I don't know. Right? And they hook themselves up to the network. Right? So let's see what happens. Nothing happened yet, right? Port status is secure up. Nothing happened. We're gonna have to try to generate some traffic. And I don't really need to set anything up, really. I just need to try to generate some traffic. I'm just gonna ping anything. 1.1 ping, right? But what we're gonna see here now is it's still up. Maybe I should actually configure the IP addresses, but we want it to be we want it to trigger a let me stop being lazy. 192.168.1.1 192.168.1.254. I really tried to be lazy just now. So let's try to generate traffic. Yep, it shut it down. Okay. I don't know if that's because I didn't wait long enough or what, but yeah, let's just still play around with this. All right. So let's check it again. So it says interface went to administratively down. Line protocol interface FA01 change state to down, right? So it's in a down state now. It's in a secure shutdown mode, right? So it created the log message and it shut it down. And the last source address is this one right here, which I'm assuming is this PC. Yep, it is. It's this PC right here, right? So it shut it down. It's not allowed, right? So the next, we're gonna do the same thing. We're gonna generate some traffic and we're gonna see what happens. Same thing, or similar, right? But let's go ahead and, because I want to illustrate something. Let's go ahead and put PC 0 back and then bring the interface back up. And then what we're going to do is shut, no shut. Okay, we're going to bring it back up. We have the IP addresses set. And what I'm going to do is I'm going to attempt, when this comes up, I'm going to attempt to ping it, right? What I'm anticipating it to do is, since it's in restrict mode, it should ideally drop the frame and create a log entry, right? So let's see what happens. We're gonna check to see if it drops the frame. So now we're gonna generate some traffic. And I'm gonna expect it to not reply. And it's gonna, see, it's not gonna reply because it dropped the frame, right? So let me see. Let's do show port security. See, security violations 10, right? So we see that despite it being in restrict mode, and it's a little less strict than shutdown, it's not shutting the interface down. It's simply discarding the frames. That's it. Protect is similar, except it doesn't create a log message, right? So again, it's not allowed to communicate, but we can, just to make sure that we have it set up correctly, right? It's probably not going to allow me to ping because I don't have IPv4 set up on switch 2. But we see that that is the case, right? So that's pretty much it for port security. I had a lot of fun doing this, and again, we had a little visit from our friend Lewis, who works in the cybersecurity field. And yeah, I look forward to, this is what I love about doing these videos, you know, networking with other people who are in the field, who are, you know, putting that work in. And yeah, so that's pretty much it for port security.